Today we will see Introduction to DSP, basic elements of DSP, applications, advantages and disadvantages of DSP, comparison of DSP and ASP. So first is Introduction to DSP. DSP is nothing but the digital signal processing. So what is actually signal processing? It is nothing but the analysis, interpretation, manipulation like sound, images, time varying measurements, values and sensor data. Basically, there are two types of signal processing. One is analog signal processing and other is digital signal processing. So, what is digital signal processing? Digital means here we use discrete signal to represent the data using binary numbers. Binary numbers means 0 and 1. Means in digital communication, data is transferred by using binary numbers. What is signal? Signal is nothing but it is a parameter or it is a electrical quantity which can be varied in such a way to convey the information. And what is processing? Processing is nothing but a series of operations performed according to programmed instruction. And what is system? It is a physical entity which is responsible for the processing. So it is a necessary hardware to perform the required arithmetic or logical operations on signal. The digital signal processing is nothing but it is a process of representing the signal in discrete mathematical sequence of numbers and analyzing, modifying and extracting the information which is contained in the signal by carrying out algorithmic operations and processing the signal. So, digital signal processing convert the signal that naturally occur in analog form. Analog form means, for example, sound, video, information from the sensor, and to digital form, and it uses digital technique to enhance and modify the analog signal data or various applications. So a digital signal processing system first translate continuously varying analog signal into a series of discrete level. This series of level follows the variations of the analog signal and resembles a staircase. The process of changing the original analog signal to a stair-step approximation is accomplished by a sample and hold circuit. Next, the stair-step approximation is quantized into a binary code that represents each discrete step on the stair-step by a process called analog to digital converter. Once the analog signal has been converted to a binary coded form, it is applied to digital signal processor. So here in converting, here two figures are shown. First one is analog signal and second one is the discrete. So here converting a continuously changing waveform into a series of discrete levels. The analog waveform is sliced into a equal segment and the waveform amplitude is measured in the middle of each segment. The collection of these measurements make up the digital representation of the waveform. The DSP, that is digital signal processing, can perform various operations on the incoming data such as removing unwanted interference, increasing the amplitude of some signal frequencies and reducing other, encoding the data for the secure transmission, and detecting and correcting errors in transmitted codes. So after a DSP processor a signal, the signal can be converted back to much improved version of the original analog signal, which is accomplished by digital to analog converter. The DSPs are actually a specialized type of the microprocessor, but these are different from general purpose microprocessor in couple of significant ways. Typically, microprocessors are designed for the general purpose function and operate with large software package. DSPs are used for the special purpose applications. So they are very fast number crunchers that must work in a real time by processing information as it happens using a specialized algorithms. The basic elements of DSP. It consists of microphone, signal conditioner, anti-aliasing filter, A to D converter, processor, D to A converter, smoothing filter. Again microphone. So here the first step is to get the electrical signal. So here we can say microphone as a transducer. So what is the work of transducer? Transducer convert the signal into electrical quantity. So here microphone convert the sound into electrical signal. So the output of microphone is electrical signal. This electrical signal, this analog electrical signal is passed through the op-amp, that is operational amplifier. So operational amplifier, what is the role of operational amplifier? We amplify the signal using op-amp. The next step, that is anti-aliasing filter. This is very essential step in the conversion of analog to digital signal. Anti-aliasing filter is a low pass filter. So it allows the frequencies up to some threshold value, and beyond that threshold value it attenuates all the frequencies. These unwanted frequencies make it difficult to sample an analog signal. The next is A to D converter. A to D converter is used to convert the data from analog to digital. The next step is anti-aliasing filter, which is a low pass filter, and this is very essential step. It allows all the frequencies and it attenuates. It allows frequencies up to some threshold values and it attenuates all frequencies above this threshold value. The next stage is simple analog to digital converter. This unit takes analog signal and output is a binary digit. Now the heart of the system is digital signal processor. So these days CMOS chips are used as a digital signal processor, as these processor units have high speed, high data throughput and dedicated instruction set. The next is D to A converter, that is digital to analog converter. The next stages are opposite to the stages of preceding digital signal processor. Now the D to A converter convert the digital data into analog form. The next is smoothing filter. It is again a low pass filter and it smooths out it gives a smooth output by removing unwanted high frequency components. The last one is the op-amp, which is an amplifier which is used to amplify the signal. And the next is transducer, which is in the form of speaker to give the analog output. So in this block diagram, the digital signal processor is a special type of microprocessor that processes data in a real time. Its application focus on the processing of digital data that represents the analog signal. So the DSP, like microprocessor, has a central processing unit, that is CPU. Also it has a memory unit in addition to have many interfacing functions. So the digital signal processor is the heart of this digital signal processing system. DSP programming. The DSPs are typically programmed in either assembly language or in C. Assembly language is used much more in DSP than in general purpose microprocessor. The DSP programs are usually much shorter than the traditional microprocessor program because of their very specialized applications. Now, what are the characteristics of DSP operations? It is computationally intensive. The next is highly suited. The DSP is highly suited to implementation with parallel. It is highly suited to implementation with parallel processor. It exhibits a high degree of parallelism, data independent. It have a lower arithmetic requirement than other high performance application For example, scientific computing. The digital signal processor are capable of performing the computations which are necessary to carry out the techniques like transformation to the frequency domain, averaging, and variety of filtering techniques. So, to perform these operations, a typical digital signal processor include the following elements, which is already seen: a control processor, arithmetic processor, data memory, timing control systems. The digital signal processing areas are in analog electronics, digital electronics, decision theory, analog signal processing, probability and statistics, numerical analysis, communication theory. The next is applications of DSP. So the applications of DSP in this, first one is a telecommunication. In telecommunication, for echo cancellation, also equalization, for filtering, that is for removing the unwanted signals, which are using specially designed filters like the infinite impulse response filter, also for the multiplexing and repeating signals. The second application is instrumentation and control. In instrumentation and control, DSP is used in PLL, that is in designing phase locked logic. Also, it is used in noise reduction circuit for the compression of signal function generators. The next application is digital image processing. In digital image processing, the compression of an image for the enhancement, reconstruction, and the restoration of an image, also for the analysis or face detection. The next application of DSP is speech processing for digital audio synthesis, speech recognition, and analysis. In medical area, for X-ray, ECG, EEG, DSP is used. In signal filtering, for the noise removal and shaping of the signal spectrum, DSP is used. In military area, for the sonar and navigation, also for the analysis after tracking in radars, the DSP is used. Also consumer electronics like music players or professional musics like DJs, the DSP is used. Also, in scientific areas like earthquake recording and analysis, data acquisition, spectral analysis, simulation, and modeling, DSP is used. The next is advantages of DSP. So, digital signal processing have many benefits over the analog signal processing. Some of the advantages are: the first one is less overall noise, as the signals are digital and inherently possess a low probability of getting mixed with unwanted signal. The entire system benefits. Thus, DSPs don't really have as much noise to deal with the comparatively. The second advantage is error detection and correction. So again, the presence of digital signal means we have to access too many error detection and correction features. For example, we can use parity generation and correction as a detection and correction tool. The next advantage is data storage is easier, as it is the advantage because of the digital signal, as the analog data needs to be stored in a tapes and stuffs like that. It's hard to transport and recreate with 100% fidelity. The next advantage is it has a repeatability, easier to process. Why? Because again a digital signal, it can easily undergo mathematical changes as compared to their analog counterparts. The next is simplicity, accuracy, remote processing, compatibility, cheaper. Also, it has a more data transmission. This is one more advantage, that is time division multiplexing is a great tool which is available for the digital system to transmit more data over a unit time and over a single communication path. Also, The next advantage, there is one more advantage, that is higher component tolerance in DSP. Components like resistor, capacitor, inductors have certain threshold in terms of temperature. Outside this threshold, as the temperature increases, it might start behaving erratically. These components are not present in digital system because as there are no any components like resistor, capacitor, inductor, there is no temperature issue. So as there are these components not in the digital system, so the digital system can increase their accuracy with the concepts like floating point arithmetic. Also, digital systems are easy to modify, because to modify an analog processing system, we need to change a components, we have to test it, we have to verify the changes. But while with digital processing system, you just need to change a few commands or instructions or alter a few lines of codes. Also, the DSP system can work on frequencies of broader range. There are some natural frequencies which detect earthquake. These signals have very low frequencies. Traditional analog signal might not even detect these signals, but the digital signal processing systems are picking up even the small disturbances and also the process them easily. The next is disadvantages of DSP. The first disadvantage of DSP is complexity. Disadvantages of DSP over analog signal processing. So the first disadvantage of DSP is complexity. As we have seen the block diagram above, there are lots of elements preceding and following a digital signal processor. So the filters and the converters add to the complexity of the system. The next is power consumption. As the digital signal processor is made up of transistors, so the transistors consume more power since they are active component. Typically, digital signal processor contain number of transistors, so it increases the power that system consumes. The next is loss of information. The quantization of the data, which is below certain hertz, causes a loss in data according to the rate distortion theory. The next disadvantage is bandwidth limitation. Also, there is one more advantage, that is cost. For small system, DSP is an expensive, costing more than necessary. There is one more disadvantage, learning curves and design time. Learning the ins and out of the digital signal processing involve the steep learning curve. Setting up digital signal processing system takes a time, and if not pre-equipped with the right knowledge and tools, the teams can be spent a lot of time in getting up. The next is comparison between the DSP and ASP, that is comparison between digital signal processing and analog signal processing. In digital signal processing, it is more versatile, but analog signal processing is less versatile. Digital signal processing has more repeatability, but it has less repeatability. DSP has more accuracy, analog signal processing has less accuracy. In digital signal processing, in DSP, signals can be easily stored. In ASP, it is difficult to store the analog signal. The mathematical processing algorithm can be easily implemented in DSP, but it is difficult to implement the mathematical processing algorithm in analog signal processing. Upgradation can be done easily, but it is difficult to upgrade in analog signal processing. Universal compatibility is possible. In analog, universal compatibility is not possible. DSP systems are more complicated because there are number of components Analog signal processing systems are less complex. It has less complexity. DSP require more power because it consists of number of transistors mounted on it, so it require more power consumption. But in analog signal processing, it has a less power consumption. Thank you.